Hello, Flat Earth researchers, debaters, and debunkers. The questions of where are we and who are we have been asked for millennia. Who knows how long humans have been trying to answer those questions, and they are both intrinsically linked. We can't know who we are, really, until we know where we are. So this is a question that any one of us will want answers to as we grow and learn to discover the world around us. And of course, this solar system model is what we are taught as we go to school. We've probably all hung planets and the sun in the classroom, or gone through a process of getting some answers to where we are, and those answers would appear to be backed by scientific explanations and of course mathematics, which are offered as proof of the concept of the theory. So what we have really as the heliocentric model is, at the crux of it, an idea that the Earth is not geocentric, which was the model put forward in the past before the heliocentric model was created by Copernicus, and Galileo backed some of those assumptions as well. We're going to look at the assumptions in this and look at the explanations that go with those assumptions. But essentially what we have is this dichotomy of changing our perception of the universe and our place in it on the Earth, from one of being geocentric, in other words, this assumption that the Earth is at the center of the universe, and changing that to this heliocentric idea, where at that time it was the sun that was put at the center of the universe, hence helio-sun-centric. And so we have this picture that we're all very familiar with these days of a solar system in which the sun is considered more or less stationary and the planets and other bodies orbit the sun, right? This is what we all know to be our understanding of where we are. And who are we then? We are people on the outside of a spinning globe that was created by a big bang just by chance, and this just happens to be where we are in the universe that would otherwise have no other reason for being. So of course what you get then is this again another dichotomy, and I would say a false dichotomy, between geocentric and heliocentric models, whereas the geocentric model is seen as something that was more obviously you could be consider it as more selfish, that we are at the center of the universe, and so there is this, it was taught as more of a religious aspect, or that's how it was seen. It was seen as a more religious outlook on where we are. So the Copernican model, although eventually backed by religious institutions such as the Catholic Church, was seen as a more just a mathematical model that started with this assumption that we are not at the center of the universe. So we are, in that sense, less important or even unimportant in the mechanics of the whole thing. Now, what happens is when you hear about flat Earth, you often get this idea that we are suddenly referring back to the ancient geocentric model or idea where we are at the center of the universe. Well, that's not necessarily the case. The flat Earth is simply a recognition that this model of a solar system requires the natural laws of physics to be broken, and you have to make up other man-made laws in order to justify the otherwise physical impossibility of us living on the outside of a spinning sphere and orbiting a sun for no particular reason other than being the remnants of a big bang and leaving everything in circles. So but that's not the case really with the flat Earth. The idea is that we understand that we may not have explored the full extent of the Earth, and it could be infinitesimally larger and wider and broader than any of us have ever imagined, because all we know is the confines of the globe Earth that we are given. And so there is no fence, there is no wall to go and peer over and go and explore. It's as if the question of further exploration has been answered for us. So with a globe in mind and the idea that everything else is millions and millions of miles away across a vast empty space that would be very, very difficult to get to and would take lifetimes anyway, it kind of keeps us also in this globe Earth concept with no apparent reason to go and explore any further than what we're given. So the real challenge here for anyone in life is to look at what we've been taught and told and really see if that is true in every sense. And when you look around us, we know that we're not moving. There's no measure of us moving. There's only mathematical calculations according to this model, which again would appear to shore up the model and make it a dead cert. But we are not taught to ever even consider any alternatives. So this model becomes very fixed in our minds from a very young age. And so it really is a challenge. This is the first challenge of approaching any of this, is to first of all accept that it's been done forever and we don't necessarily have any answers that actually mean anything. We are just living in a time now where this particular model was adopted, and who knows what kind of process was gone through in order to create this consensus. But of course, the issue here is that we are given this impression that this is the best model we've got, so we're sticking with this until something better comes along. Well, of course, they're talking in terms of science and mathematics, and well, what if the mathematics works in this, then for the most part, people are just going to ignore any other suggestions that come along. Now, one of the really important things to remember as well when we come to discussing things like where we are is, okay, first of all, assume that we don't actually have the answers. We have assumptions, we have theories that have never been fully proven in the scientific way that would involve physical measurements, okay, apart from abstract mathematical calculations. Big difference there. It's very important to discern between that. A calculation is just a calculation. You can do it on a piece of paper, and it's an imaginary concept that can make sense in itself, but can it be proven or measured in reality? Okay, that is a very important discernment to have in all of this. And again, the discernment to realize that what our teachers have taught us is only what they were taught, and maybe they didn't think beyond that. So you're allowed to think beyond what we are told. It's perfectly acceptable, because it's your question. Where am I? Where am I? Who am I? As a consequence of where I am. Yeah. So it is important, and ultimately, we can all find our own individual answers that have a real meaning to us. But that can often only happen when we are able to at least detach from the concepts and the models and the thought experiments and consensus that we have been raised with. So regardless of what you believe, it's important to understand that nothing changes about what we see on the earth and up in the sky. Nothing changes. It is important to understand that it is our perception of reality that changes, or can be changed, can be manipulated, can become consensus, manufactured consensus. Not because everyone agreed and everyone was questioned and everyone put deep thought into it. No, it's just because a certain certain people wanted certain solutions or ideas. Now, one of the things that I consider the heliocentric model to be is an attempt to standardize everything. And it kind of comes about in around the same time as other ways of standardizing our lives, especially time, with the introduction of the Gregorian calendar, which is really based on a heliocentric model. So it's a solar calendar, all right? And so we know that time dictates our lives significantly, but it's really conceptual, even when you talk about 24 hours in a day and trying to round things off. So the heliocentric model in that respect is one that adheres to a solar calendar. So we're basing our time and our concept of time and where we are and when we are in time on this heliocentric idea. We're looking at the sun to tell us the time, basically. Whereas, of course, in many cultures and still today, we can follow a lunar calendar, okay, and that brings us to the same kind of yearly cycles, but a little bit different, but more consistent, because lunar cycles are consistent, whereas the sun's cycle it varies a lot more, and so and it's not a round number, as it were, so you can't really round off a year to a full orbit and all those rotations of the Earth, so you end up getting all these discrepancies in time management. For example, leap years, and you just can't standardize this model of where we are and our timekeeping in a way that really fits with this heliocentric model. But you can get very close, and when things are rounded off and degrees are used as well as for timekeeping and distances, then you have a model that you can obviously create a geometric illustration of, which is what we have here. So, of course, the heliocentric model was one that wanted to assume that actually all the planets do circles around the sun. Whereas you can see the image below me here, and keep in mind what I was saying about nothing changes, is that we have the paths of these planets, or what would the ancients referred to as wandering stars, Mercury, Venus, Mars, Jupiter, Saturn, as we see them from the Earth, okay? So, nothing changes about what we see going on in the sky, but the geocentric model with the idea of the Earth being at the center of the universe and having basically used the same observations of these planets, doing these spirals and making these patterns over courses of years and decades and centuries. And so that's how that model is illustrated, with the Earth stationary, like the sun is stationary in the solar system, and the planets and everything doing their thing in the sky as we see them. So the model has changed, or the consensus on the model has changed, to this Copernican solar system model. And nothing's changed about what we see in the sky. We still see Mercury and Venus and Mars and Jupiter and Saturn apparently doing these same paths over a long period. All right. Now, so what happens in the conversion to the heliocentric model is this observation that has never changed over hundreds of thousands of years now has a new explanation. And so, for example, Mars and or Mercury, it has this what's called retrograde. So what appears to us to be this apparent loop, obviously we are creating a model that assumes that we've kind of jumped outside of the Earth and everything, and we're this godlike view, and so what that is assumed to be this is the retrograde motion, which is basically because we now consider the Earth to be moving in its orbit, and the other planets, for example Mercury or Mars, also moving around with us, but at a different rate of speed or orbital velocity, however you want to term it, then our view will change of that planet. Okay, so we have another explanation for the retrograde motion. This apparent, what happens is from our view, for example, we might see Mars be going across the sky in a consistent pattern night after night and making progress, but then there'll be a period where it appears to become stationary and maybe go off into the distance and come back again, and then continue on its conventional journey of traveling across the sky. Okay, so that's put down to being retrograde motion, because the Earth is just in the relationship between the Earth and that planet at the time is causing us to see this pause in its circle in the sky. Okay, it's another explanation, but so that's why you can then have the circles and of the planets without this wonderful geometric pattern that we see for the other planets here. Yeah. So, it's perception, all right? One or the other could be true, or possibly neither could be true. Something else could be going on. And again, that's what it is with the flat Earth, to basically assume what we see around us as being level and stationary. We don't have to assume that we're moving, and we can also understand that other models work. They do work as far as predicting and recording the observations that we can make. But this doesn't say anything about the mechanics of it. And of course, the mechanics of the solar system was then later defined by someone like Newton, making up laws like mass attracts mass, and being able to measure the rate of acceleration that a solid object falls to the ground, 9.8 meters per second. So then we have a rate of acceleration that we can attribute to a force of gravity, F equals ma, right? This was the famous equation that Newton apparently came up with to just come up with a formula that explained. Again, it's just an explanation. It's a mathematical explanation. It doesn't prove anything. It doesn't prove that the sun has a mass that is pulling all the planets around, and they are traveling around at certain speeds. Yeah. So there's all sorts of contradictions that come into mind, aren't there? That, for example, okay, we're whizzing around the sun. Now, in real physics, in real life, regardless of where gravity is pointing on this Earth, or any assumptions you make about the Earth being the cause of a gravitational pull, if you get a bucket of water and you put a string on that bucket and you swing that bucket around your head or around your side, we know that the water will stay pressed into the bottom of the bucket. It won't fall out as long as you're spinning that thing fast enough to overtake its gravity, so or its density. Yeah, centrifugal force. You just need as much force as there is density of the object on the end of the string, and then away it goes. So of course, the more force you put on it, the more pressure. That way you're creating outward pressure. So you can call that gravity as well. That's real gravity in a way that we can actually create. So of course, you attach that scenario to something like the solar system here, and the mind boggles, because according to the physics that we can practically demonstrate anywhere on the Earth, this idea that the Earth is spinning around the sun, and it's supposed to be going fast enough to stop it from falling into the sun. Yeah, so it's going really fast. Okay, you, in that case, if that's what you imagine, you have to assume that there's this vast space between the Earth and the sun in order to travel this massive distance that would allow it to travel fast enough and complete a circuit in 1 year, for it to be held in place without falling into the sun, with all these ideas about the orbital mechanics are based on mass. But of course, that raises problems. How come the water on the Earth isn't kind of sticking to one side? And in a way, this system would work. For example, on a flat Earth, you could say, okay, you've got the flat Earth coming away from the sun, and all the water and all the land is facing the sun, and that is what's keeping all the water and everything and keeping us on the Earth as we travel around. That idea, if you imagine the Earth, a flat Earth attached to a string coming from the sun, right, to create this centrifugal force that would hold us to the Earth, that would actually make more sense. But of course, the issue is that you would then have a constant day. You would never have darkness unless you were on the underside of the Earth. And of course, the moment you did that, then you would leave the Earth behind. So it's either way, if you imagine this solar system concept, there are immediate flaws or things that do not fit with reality. So we have to come up with mathematical concepts, and the idea of gravity holding us on, and everything's just right that we don't feel anything. It's quite funny though, because the centrifugal force or the speed, that we should be experiencing at the equator compared to somewhere quite high up north on the Earth is quite significant. We're going about twice the speed at the equator apparently as we are further up north. So there's double the speed that's being done as we spin, which in itself would create a centrifugal force, as well as the centrifugal force of the Earth being thrown around the sun. And so it becomes ridiculous. It really becomes quite ridiculous. And the only proof, as we say, is mathematical concepts. No one ever discovered curvature. No one ever saw, there's a curve there. And so we must start to work on the theory that the Earth is curved or spherical or something. No one ever saw or measured a curve, ever. So that's why you have to have mathematical explanations put onto this model. So, of course, these explanations are what are dished out to us as we kind of, we question the model ourselves when you're young. Hang on, how do we stay on the Earth if it's spinning? And then, okay, the concept of gravity is brought in. So it appears that it's all been worked out over the years. Yeah. So essentially what I'm coming around to now is really just going through a list of the assumptions that were made to create the heliocentric model. And let's just go ahead and question, as individual scientists exploring this world, what those assumptions really mean, and do they really mean anything? Yeah. So right, here we are with Copernicus's parallel assumptions. So these are assumptions based on the previous Ptolemaic model, the one put forward by Ptolemy, and there were other models by Aristotle. So the ancient Greeks, and again, have all been putting forward their own models and ideas. Okay, but when the Copernican model came along as an alternative to the geocentric model accepted at the time, we have the first assumption that the universe is spherical. You can see at the top there. Well, okay. Now, obviously, there's this idea that the universe is expanding and all that stuff. Again, it's not anything we can really prove, but maybe we could say there's nothing really wrong with that assumption, but it is obviously a necessary assumption that the universe is spherical, or the universe, as far as we can see it, is spherical at the time. Okay, and number two, of course, that the Earth also is spherical. Now, this is an assumption. It wasn't derived from any measurements. It was a necessary assumption for the model, just as we talked about. Let me just bring that up again. Where was it? The solar system. Just briefly bring that up again. Again, the Earth is considered another planet. It's considered spherical, and we've got these circular orbits as well. Okay, it was just that's just how it was considered, and just oops, right. Now, of course, that creates problems, as we pointed out earlier, the Earth being spherical in many, many ways. But then we have this third assumption that how Earth, with the water on it, forms one sphere. So again, you have this idea of a globe of water, and most of the Earth is covered in water, and you have to assume bendy water. You have to assume that water can somehow cling to the outside of a sphere. And again, this wasn't something that was mathematically defined with gravity in this era. You know, Newton came along later on and saved the day with his formulas, and that's part of the reason why you're not allowed to question Newtonian physics. He was considered a hero. It's almost like questioning any kind of prophet for a religious doctrine. Okay, so these three assumptions, and then 4, that the motion of the heavenly bodies is uniform, circular, and perpetual, or composed of circular motions. Okay, so as we looked at earlier, we're not actually seeing anything different in the sky. We're just interpreting what we're seeing as everything doing a circle. So making the Earth do a circle among those other planets allows you to pass off these observations of the paths traced of planets as being circular, roughly. You know, there is, who knows what was really discussed, who knows how what was really discovered and found out, and what kind of holes in the model might have been overlooked, but as time went by, explanations and excuses were given for these assumptions. Now, the other one, this one is an important one, number 5, whether circular motion, well, they're all important really, but whether circular motion belongs to the Earth and concerning its position. Okay, so you've got to incorporate motion. So when you look at the night sky, we look at the Earth, and it's not measurably moving. There is nothing really about what we experience on the Earth or can measure on the Earth for us to assume any movement. But of course you have to assume it for the model. You have to assume there's spin, there's orbital stuff going on, and all that. Okay, it's a massive combination of movements, all because you assume that the Earth is a planet. So again, this is lumping in the Earth as another planet, and having to assume that it moves. Now, number 6 is of the vastness of the heavens compared with the size of the Earth. So this, of course, is another thing that's been repeatedly told to us, that we're just an infinitesimal speck. We've got the occasional photograph from a Voyager satellite that's supposed to be millions of miles away, taking a picture of the Earth being lit by a ray of sunlight, and other things like that. And of course, the idea that the universe is continually expanding. So this, again, the vastness between the sun and the other planets is necessary in order to have them go at these amazing speeds in their orbits, in order to have enough space and distance for them to complete an orbit in one solar year. So then you can talk about the stars being billions and miles away and light years, and it becomes inconsequential, and we're basically saying here that there's no need to measure that, there's no need to confirm it, we just assume that everything's really far away. Okay, again, this goes against our senses, it goes against what we know and experience, and we are all experts in this. No scientist and a mathematician can really tell you anything more than what you experience in your body. We look at horizons, they are our eye level. Everything about our senses is our survival tools for the Earth, for the world. Yeah, we would know if it was curved, we would know if it was spinning, and we would there would be so many things telling us telling our senses, but that doesn't happen. All right, and again, it's not measurable either by any scientific method. So all of this is just assumptions that have been loaded into an assumed model. Yeah. Again, with the flat Earth, there's no assumption on the actual size of the universe. As we could be on an infinite plane. We could be just one of many places that have, who knows? Who knows? That's not. That's what's important to understand about talking about flat Earth, is that no one's trying to confine you in a model that puts you in a certain place in the universe or a solar system or whatever. Yeah, and this is a big problem that people have, and this is why I'm going through these assumptions so that you can see that they are assumptions, is because people can't. It's very difficult, understandably, to imagine a flat Earth and then this with a massive sun like we've been taught. You've got to completely disregard the model, put it aside, the model that you've been given. That's the challenge. Yeah, and that's not a religious thing. It's not dangerous. There's nothing wrong with that. It's okay to question. Yeah, but you have to be able to completely detach from all these assumptions that we've been given here for a model that we've been shown since childhood. It's challenging, but you don't hold on to any aspects of the globe or heliocentric model. None of them. The size or the distance to the sun. Put it away. Forget about it. What is the sun? Is it a burning? Doesn't matter. We can't prove it. We don't know it. Put that aside for now. Even if you think you know, even if you're very attached to that belief. In fact, the attachments that we have to these beliefs are precisely why you should be challenging them with anything. This could come down to your views on race or gender or all sorts of other things, lifestyle. These are all things that we've been conditioned to think in a certain way about. And so the challenge here is to completely put those aside. You can put them aside and pick them up and come back to them later. That's okay. But if you want to progress in any way, if you want to develop yourself as a person, as an individual, and know the difference between what you can and cannot prove, or what you know and what you believe, these are essential for life in general. Whatever you're doing, whatever you're thinking about, whatever course your life is taking. Yeah? These are essential tools for any situation. Choosing a partner or whatever you're going to buy next or not buy. Discernment in how you can develop an attachment to a belief and how difficult it is to let go of and consider something else that goes against what you have been traditionally taught. Now, you can go into the psychology of all that if you want, but essentially that's what you have to do. Yeah? Understand that these are all assumptions. That's all they are. Necessary ones to come up with a model with the idea of creating a standardized measurement of time. And again, in order to fit with the Gregorian calendar, which is what we use today, and it's mostly for commerce. And I've said before, there's nothing wrong with developing a standardized method of timekeeping, but that doesn't mean that's what the stars and the planets and the Earth is doing, or the sun and the moon. Essentially, those are the things that are really tied to our perception of time, the sun and the moon. So we've been given a choice. We've been told to follow the sun. Follow the sun. The sun is at the center. The sun is the idol of the heliocentric worshipping going on here. It tells us when we get up, when we go to sleep, when we eat lunch, when we retire. Yeah? When you get paid. That's what this is. That's what the excuse me, chrysanthemum tea. That's what we're being That's what this model has been put in place for, to tell the time in a standardized way. All right, now, I digress, but I think it's an important point. Number 7 of the Copernicus parallel assumptions: why the ancients believed that the Earth is at rest like a center in the middle of the universe. Okay, so again, we kind of touched on that earlier, that when the Copernican model was introduced, the heliocentric concept was considered a religious one, and here we've got science to push aside that more spiritual or personal, subjective view of who we are and where we are, to one that's more objective. Okay, again, this is standardizing it. So you have to think in terms of standardizing. You know, when you think about this, when you think about how we can often be led into certain beliefs, political beliefs, because you're doing what's good for the community. Yeah, we know that people can be persuaded to think that they're being selfish, to consider themselves at the center of the universe. And so instead, you do or you think or you believe what's right for the party, for the commune. Yeah? You understand? Number 8, the insufficiency of these arguments and their refutation. Okay. The insufficiency of these arguments and their refutation. So it's funny, because what they're saying here is, this is the best model we've got. You'll often hear that repeated. Well, the heliocentric model is the best one we've got, so we're sticking with that one, because that's the limit, that's the peak of our understanding at the moment. So until someone comes along with a better model, then I'm going to stick with this one. That's the thought process behind this. And so, but that's funny. It's ironic, isn't it? Because they're saying that there are insufficient arguments in the geocentric Ptolemaic model, and but then this is the whole thing with when it comes to flat Earth, globe Earth. Well, there are insufficient measurements or arguments for any curvature. There's nothing. There is no measure of curvature. There is no measure of spin. There is no measure of orbital speed. None of this. There's a lot of insufficient, and the fact that water doesn't curve. Yeah, it flows on the Earth. So in reality, measurable, physical, demonstrable reality, there are a bunch. There's a whole host of insufficient arguments to prop up the Copernican model. But here they're saying the Copernican model is the best one since sliced bread, and the arguments from the geocentrists are insufficient. All right, slight interruption there. So that was number 8. Basically, there are insufficient arguments or measurements or anything for the heliocentric spinning globe model. None. And, well, of course, the idea that we've been to the moon and there are satellites going around the Earth, rockets, etc., would appear to be sufficient proof in many people's minds. Again, it's very difficult to get past that programming where people have been going into space for a couple of generations now, and it would appear to be irrefutable at first. But you look into it and you realize, okay, things aren't quite right here, or there's a lot that we're not being shown. And there's a lot of money being made in the process to perpetuate this idea of infinite space and planets that we have to spend lots of money to get to. Now, number 9 is whether more than one motion can be attributed to the Earth and of the center of the universe. Okay, so this thing about motion is again important to understand, that, as we were saying earlier, you can't detect any motion. There's no measurable motion of the Earth. So it's an assumption. It's assumed that we're moving. It's not measured. It didn't come about, oh, we must be moving. That would be real science. You make an observation that the Earth is moving. Oh, okay, now we measure how fast we're going. And then you would make a prediction. I predict that within a year or whatever, or in a day, we will have moved from this place to that place, da-da-da-da-da. And so that's that. In some ways, that's how these predictions, because you can make predictions about when sun will rise and set, you can make that fit to this heliocentric model mathematically and say, oh look, well it's with a circumference of a certain size of the spherical Earth, we'll travel this far in this amount of time, and that gives us the daylight and the nighttime hours. Yeah. So that is also important to this, because obviously it's assumed right off the bat. There's no, again, this very tunnel vision thinking process is that the only way we can have day and night on the Earth is by having the Earth turning to create day and night, right? It's just assumed to be. In fact, a lot of people will come up with that as the only or the predominant reason that it can't be anything else. And of course, in the model, it can't be. As we saw, the sun would be constantly on one side or the other in the heliocentric model if the Earth were still level and stationary for that model. So of course that's again why the distance of the sun comes into it as well, or the assumed distance. However, it's all down to interpretation. All right, we see the sun move across the sky every day. In the heliocentric model, we're told it's because we are moving. All right, well, it's one of those things where you can't really tell if you can't really feel any emotion either way. Yeah. And then the stars. Well, you could assume that we are seeing the stars move because we are moving. And then the moon. Is the moon moving? We're told that the moon moves orbits the globe Earth every 28 days. But actually, what you can observe is the moon goes overhead just like the sun does. But they are going around at different speeds. So this is a really important aspect of it as well, to detach from that heliocentric idea that the Earth's movement is what's causing the apparent movement of everything else in the sky, as well as their movement. So here, of course, the heliocentric model assumes that everything is moving except the sun. But you could base your model on all sorts of things, and you could say this is moving, that's not moving, and that's not. And who would be any the wiser, really, because you just claim it to be so? Well, it would come down to measurements, wouldn't it? But you see, you can perceive us seeing the moon every night in a different place in the sky, because you're assuming that the Earth is spinning and the moon is orbiting the Earth just once a month. But why not just consider or assume, for the sake of exploring other ideas, that the Earth is stationary, the sun moves, and the moon moves, and the stars will move together, and other stuff kind of does whatever in who knows what kind of environment. Okay, you want to assume the universe is a sphere. You can do that if you like, but where's the universe? Where's that? These questions don't lead to any real conclusions or the answers that we can make from the interpretations of what we see. Don't lead us to any. It still doesn't help us meet our maker, really. It doesn't tell us where heaven or God is, or what created it, or how, or why, or when. None of those questions really get answered, do they? They don't. So it's perfectly okay, again, to question this, but in order to question it, you have to understand that we've been indoctrinated with a bunch of assumptions and explanations passed off as science because you can make some mathematical models from it, and told to accept them as absolute truth because it's much better than anyone else ever came up with, according to the history books. Now, as we know that history is always changed by the winners, who knows what actually went on, who knows what Galileo experienced, or whoever, it doesn't, we don't know. But what we do know, if you think about it, is that we can be told certain things by figures in authority and will, for the most part, accept them because that's the first answer that we are given, and it often puts an end to the questions. And so years down the line, when someone asks you the question again, you laugh because that question was answered when I was 5 years old. And yeah, it just becomes rock solid. But any of us who are trying to progress in life and really learn about who we are and where we are, even if we can't find those answers in a physical format, we'll ask these questions and continue to ask these questions, and know that it's okay to ask the questions. But it's also tough. It's very tough to detach from all these assumptions. So that's the challenge. That's the challenge. Explanations mean nothing. Do they? Because you can come up with any explanation you like. The dog ate my homework. And what difference does it make? The difference is that, well, you didn't do your due diligence anyway. You didn't do your homework. So you're going to make excuses for not being able to produce what was asked. Where's the measure of the curve? Where's the measure of the spin? Where's the measure of our orbit? Or is it just a bunch of interpretations and assumptions? Once you're able to discern between those, again, knowledge and belief, consensus and fact, then you can start to explore who we really are and where we might be. Thank you very much.